So similar triangles. So up until this point, like I said, with the similar polygons, we had to make sure all the angles were the same and then all the sides had the same ratios. No longer the case. When we have similar triangles, we just have to look to one of three things. All right, the first thing we can look for is angle-angle similarity. So if we have angle-angle similarity, that means that we just have two triangles where we know two angles are the same measurement. So if two angles of one triangle are congruent to two angles of another, then the two triangles are similar. So for example, so here's my two triangles. If we are told that this angle is 30 degrees, and this one can be 50. Oh, let's actually make that 90 and not 50. Okay, so if these are both 30 degrees and these are both 90 degrees, if that's the case, we'd say that these two triangles are similar by angle-angle because they have two angles that are the same. Okay, so this would be angle-angle similarity. So that's one way we can tell that they're similar. Okay, if we have the two angles the same. Second way we can tell that they're similar is side-side-side similarity. So what do you think side-side-side similarity would be? We're only looking at sides, right? What do we have to know about the sides for side-side-side similarity? Not the same, but the measures of the corresponding sides are proportional, so they all have to have the same ratio. James, pay attention, don't sleep. Okay? No, I'll leave that one in YouTube. All right, so side-side-side similarity. So what that tells us, if we have two triangles here, we don't know anything about their angles, nothing. But if we're told that, let's see, 8, 10, and 6 are the sides of this triangle, and then the other triangle is 4, 5, and 3, don't whisper to each other, pay attention, or move to the front table. If these are our two triangles and we want to decide if they're similar using side, 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 we would check out the ratios. Okay? So we'd go, okay, 8 to 4, so 8 over 4, is that the same as 6 over 3, and is that the same as 10 over 5? Yes. Yep, they are. So when we have triangles with this, these are similar by side, side, side similarity. Okay, so we don't need to know anything about the angles. We can just look at the sides. All right, and then the one last one here is side-angle side similarity. Just like when we were doing the triangles congruent, we had a side-angle side. It's a similar idea here, except for we are just looking at the two sides are proportional to each other and that the included angle are congruent. Then they can be similar. Okay, so first off, for it to be side angle side, the angle has to be the same. So is the angle the same? 30 and 30, are those two the same? Yep. So now we have to check to see if the sides are proportional. So we'd go, does 10 over 5 equal 12 over 6? Do those two equal each other? Yes. So these two would be similar by side, angle, side similarity. Okay, so those are our three ways. So we are looking for two angles being the same, three sides all having the same ratio or being proportional to each other, or if we only know one angle, then we're looking for the two sides surrounding that angle to be proportional. Okay, so we're going to try a couple of examples, just deciding whether or not triangles are similar. So we want to decide if the triangles are similar, and then we need to justify our answer. So this first example. We always want to look for angles being the same. Okay? Because if we have two angles the same, we can say that they're similar. So that's always the first thing we want to look for. So here, how many angles do I know are congruent? One. Just one, right? I just know that these two are 90 degrees. Okay, if we only have one angle congruent, we want to see if we might have side, angle, side. So in this first triangle, to do side, angle, side, I would need 4, the angle F, and then that side. Do I have a measurement for that side? No. So right there, we can't say anything about this. So we have not enough information right now with the way things stand. Now this is a right triangle. Can we find missing pieces of right triangles? Using the what? Talked about it early on in the year. It starts with a P. Pythagorean theorem. So let's find that missing side. So a squared plus b squared equals c squared. Which side is my c? Okay, so that's the 8. And then my other side's 4. So we have 4 squared plus b squared is equal to 8 squared. What's 4 squared? 16. What's 8 squared? 64. So I subtract 16 over, so I get b squared is equal to what? 64 minus 16. 48. And then how do I get my b? Square root. So what's going to be the square root of 48? We'll use your calculator. Square root of 48. What is that about? 6.9. Okay, so that side is 6.9. So 6.9 here and 10 would go together. So we'd say if 6.9 over 10, does that equal our other side's 4 over 5? Are those two equal? No. So these would be not similar. These are not similar because the two sides are not proportional to each other. They don't have the same ratios. All right, so let's look at the next one. Here I've got two triangles. This first triangle, I know that these two sides are 8. And I have angle B marked as congruent to angle D in the second one. In the second triangle, I have these two sides being congruent. What do we know about triangles with two sides that are congruent? They're isosceles. So if two sides are congruent, what else are congruent? The angles. So that means B here would have to also equal angle C, and D would also have to equal angle F because they're isosceles triangles. So now let's look. In this diagram, do I have two angles marked congruent? Yeah. I have angle B and angle D being congruent. And I also have angle C and angle FR. So, triangle ABC would have to be congruent to, or not congruent, sorry, would have to be similar to triangle. Well, if I started with A over here, I have to start with E. So EDF, and we'd say by angle, angle. Our justification here is writing down the fact that those two angles are congruent, and then we would also put down a similarity statement if it asks us to. Is that okay? So the only example we didn't do here was side, side, side. But we did quite a few of those types of problems with the polygons the previous couple days. All right. So what we're going to do next is I'm going to give you a diagram. And from this diagram, we want to find some missing information. Okay? So in this diagram, we have two overlapping triangles here. And we are told that FG and EG are congruent, which we have marked on the diagram. We are also told that BE is 15, CF is 20, AE is 9, and DF is 12. We want to determine which triangles are similar. So first off, we always want to look for congruent angles. So if these two sides are congruent, what can you tell me about this little triangle down here? About that little triangle, what can you tell me? Not an equilateral, it's isosceles. So if those two angles are equal to each other, what can I say about those two the angles are, right? Whoa, I wanted the eraser, not the highlighter. There we go. So that means these two angles have to be the same. So what I'm going to do, when we have triangles that are overlapping, a lot of times it's easier to see if we unlap them. So if we kind of pull them apart from each other. So I'm going to take this triangle A, B, E, and I'm going to draw it separately from the other triangle, F, C, D. Okay, notice that E and F are still marked congruent. Now let's label our two triangles that we drew separately. So BE here is 15. CF, so here's CF, it's 20. AE is 9. And DF is 12. So how can I decide whether or not these triangles are similar? I know one angle is. I know E and F are. So what should I do with my sides to determine if these are similar or not? What should I do with my sides? Put them over each other. So 15 corresponds with which one? 15 over, 20. Does this equal, then we have to go to 9 over 12. So are these two equal to each other? Well, let's look. Can they both be simplified? Yeah. Okay, so 15 and 20, what can we divide each of those by? 5. So if we divide these each by 5, 15 divided by 5 is 3 over 4. Does that equal? 9 and 12, can we divide each of those? By 3. So 9 divided by 3 is, so they are the same. Or you could have just divided them to get 0.75 for each to see that they are the same. So these are the same, so they're similar. What type of way did we use there? Did we use angle, angle, side, or side, side? Side. There wasn't a side, side. Angle, angle. So did we look at two angles? We only looked at one angle, right? So it's got to be the side, angle, side similarity. And now let's write the similarity statement. So triangle. How do you want to name this first triangle? A, and then what angle do you want to go next? A what? E. ABE is similar to triangle. If we started with angle A in the first triangle, which one is going to be corresponding with it? D. Then we went to B, so what would be the one corresponding with B? C, and then F. So that's how we decided. All right, we're going to do another one that's similar to this.